Hello friends, welcome back. In this video is just going to be a short one to correct one little problem that we noticed in the last video where we could not put the order of these methods the other way around. So this call to bar errors because it doesn't know about the method bar yet, and I think we could fix that really quickly. If we change a little bit of how we do dependencies on methods. So what I was thinking is we could actually have a new thing called method dependency .new, and we'll say that the name is name and the hash of methods, we'll just pass that in. Now there's a little bit of I don't know, coupling here that if this was a proper architecture, I don't think I would share this this hash like this, but I'm just having fun and I don't care. So sue me, I guess. The method dependency. So we need to go invent that method dependency. We don't have that yet. So let's do something like here. Method call arg dependency, and we'll save that as method dependency. Method dependency, this is the name, and then this is the hash of methods that will be mutated. Name, and then we'll do something here, raise to do. Okay, and then let's restart our little runner here. Okay, so now we're getting the to do, that's perfect. Here we'll say method is at methods.fetch name, and I think we could just call method.type on this. Yes, so now compiler spec this actually, it was in VM spec. Yeah, here actually that should be a compiler spec, I think. So let's reverse this one. And that, oh, that broke this. Fair enough. So we'll put this up here. Okay, good. So now let's just commit the changes that we want here. The compiler stuff, yes. Compiler spec, yes. VM spec. Yeah, sure, why not? Do I want the VM spec? I did change the order here, but I think that's fine. Okay, I'm back. I couldn't do a video that short. Nobody's gonna want to watch that. So let's go and work on if expressions in this same session here. And what are we gonna need for? We're gonna need a compiler spec. It compiles if expressions. Yeah. I'll say code is something like this. If 1, then 2, else 3. Yeah. And what do I want that to compile into? Compile code must equal type is int, instruction is if followed by the condition. No, just if. And this will be end if, and similarly to our end def, this will always have a type of nil. The condition is pushed onto the stack, so this would be type int instruction push int 1. Okay, we're also going to need an else, so that'll be here, and the body of each condition, each clause, the true and the false side, we need those instructions. So 1 2 3 else. That's what I want it to compile into. And we'll worry about running it later, maybe not in this video, but we'll just worry about compiling it into these instructions. one if compiler, and oops, I went too far. Call, okay. When if, let's print the node. Let's see what that looks like. So it has the if, it has the condition, and then it has a true body and a false body. Now I assume that if this had more than one thing in it, it would return a block. Very good. Very well. So we want condition, true body, false body is destructured from the node. And ooh, what are we going to do here? Well, I suppose we'll say instruction is instruction.new and an if, and there's no arguments. And then we'll say instructions, instruction, and we'll return this instruction because that's the one that will have the type information. But we also want to do instructions end if. Is that right? Yeah. End if, and we also need an else. And then we need to transform the true body and transform the false body. Okay, does that get us something? Yes. Instruction RB36. Let's return nil for now. We never got around to writing this message. That kind of bothers me. That's okay. So there's that, and then the compiler spec, we need to must equal, what was the name of that thing that we had? Expectations. Must equal with diff. that will be helpful with diff. Yeah, oh, here's our diff. So the difference is that we got, oh, we didn't push the condition. Okay, so we need to work on that. Compiler, and we'll do instructions, actually just transform condition. That should do that. Okay, so now the only difference is that we don't know the type of the result of the if expression. So we need to work on that little bit. And so that means that our instruction needs a dependency, and the dependency is what? Oh, it's the true body, true instruction, or say true, yeah, false instruction. It's not actually, is that right? Yeah, I guess it is. True instruction, false instruction. And then the if expression itself has two dependencies on the true instruction and the false instruction. Maybe. That didn't change anything. But why? Why did nothing happen? Well, I assume this is going to raise an error, yes. And which spec are we on? We're on spec line 138, which is here. Very good. So what has gone wrong? Instruction 37, 15. Let's print out the dependencies for this test, but actually let's only focus this one test because I don't want to print this out a bunch of times. Dependencies. Yeah, it has both of those. Oh, this is the first time that we have more than one dependency, but they both agree on type. So this, we need to do something here. We need to say unique types is at dependencies.map type dot compact dot unique, and we'll say if unique types size 1, then we'll just do unique types dot first, else raise, we'll say if it's 0, then raise type error. Let's go copy, we had another type error. We'll just copy these two. So this one goes here, and this one goes here. We'll say not enough information to infer type of. I don't know. I don't know what to say here because I don't know what it is. Well, for now we'll say instruction, and then we'll do name. Yeah, probably not the best error message, but better than nothing. Instruction name could have more than one type, and then unique type sort inspect. Not information to infer type of instruction else. That's right, because else has no type information. Same thing with end if has no type information. And we got a passing spec. Okay, very cool. And let's just verify that it raises an error if both branches of an if expression do not have the same type. And we'll say we got some code here. So this is going to be foo, and we'll say expect compile code must raise type error, expect e.message must equal foo. What do we want that to say? Yeah, that's pretty much what we want it to say. And double quote that. Ah, it's beautiful. So we got our error message for free because of our dependency tree that we've been working on since the very first video. Yeah, I love it when we get stuff for free. That is so cool. Did we, we're running the VM specs as well, right? Just want to make sure. So what are we running over here? We're running rake spec. Is there a way to get, is there a way to get like the describes, like the test names and stuff? Require rake trace tests. I guess not. I think this is all just rake. Yeah, that's all just rake stuff. So what if I do Ruby spec compiler spec help? What do we get there? Verbose name skip extensions. Okay. No, I think I would have to install a mini test formatter or something. Let's just go look at that. I don't know. I'm curious. And I guess if you want to, you know, sign off what's going on here? The video's over. I'm just goofing off now. Mini test doc reporter. Not minis test, mini test. There's a doc reporter that has 0 stars. Maybe I want mini test reporters. I think that's what I've used in the past. Spec reporter. Don't like the default progress bar. Oh yeah, look at this progress bar. Ruby mate, Ruby mine. If I do the spec reporter, mini test reporters. We'll try that. Gemfile mini test reporters, spec helper. I suppose I need, yeah, I just need this line. Probably though need it up here. And let's see if this can work. Okay, I didn't like that. I gotta do require reporters. Oh, that's cool. So now we can see our tests and see some of our progress. Very cool. Yeah, I guess it runs them in like a random order. That's fine. Evaluates integers, strings, method definitions, variables get and set, definitions, argument. You know, oh yeah, let's go do the VM. Let's go do the VM stuff. Where am I? VM spec. Oh, this is not compiles. Evaluates. Okay. Evaluates if expressions. Do. Yeah. Evaluates if expressions. This will be something like if 1, 2, else 3. Now we don't have anything that will ever evaluate to false currently. Everything is going to be true, even 0, because I'm kind of doing what Ruby does. The only thing that's false in Ruby is false and nil. So we don't actually have a Boolean type yet, but that's okay. We can at least see something happen here. So this should be a 2. So now we should have a failing test. Unknown instruction if vm.rb, and we'll say when if condition is stack.pop, and we'll say if condition, which in Ruby means, if it's not false and not nil, then we this is gonna be tricky. I think we're at the right place for a true condition. We're at the right place. So their index is correct. It's off by 1, so we'll do index equals 1 to execute the true. No, we don't want to increment it because we incremented up here. We do just want to do nothing if it's true. If it's false, no op, just execute next expression. If it's false, we need to go to the next else. We need to until. We'll kind of copy. Where's our until? We'll kind of copy this one. Until instructions index name is else, then we're going to increment. Now, what if there's an if inside of an if? Okay, for now I'm just going to leave it like this because I don't have a failing test for that, but we'll come back and we'll prove that's not sufficient. So we get to the else, and then we execute, or then we stop. And that also means when we encounter an else, we need to skip over all of the remaining instructions. So the same thing here. We'll say end if. Yeah, I think that's what we want. That actually worked. Okay, but it doesn't work with falsy things. How can we test that? Well, we can do the nestedness here. We could say if 2, 3, else 4, 5, and we should get back a 3. But that's, oh, why did that work? I'm going to need a false in order to test this. Okay, we're going to add a false real quick. Compiler spec. Don't worry, the VM spec. We'll say if false. And I know you're going to freak out because you don't know what false is. Unknown node false. Compiler spec. It compiles true false. True must equal type bool, we're going to need a new type, push true, and this is going to be false, push false. We'll say bools, Booleans. Okay, that's the one I want to get passing first, so let's just focus that for a second. Unknown node true. Compiler, this shouldn't be too hard, I think. Let's say when true, false, instruction.new push true. And we'll say like this. Yeah, and this will be push false. Not enough information to infer. Type of instruction push true. Because we already know the type. Type bool. Okay, very good. And then we can unfocus this test, and now we're back to the if expression, unknown instruction push false. Okay, VM spec. Let's skip this for a second, and let's go down to here, and let's say evaluates Booleans. True must equal true, and false must equal false. Yep, and then VMRB, we'll say push. Yeah, push true, stack is true, push false, stack gets a false. Okay, expected true, actual. Yeah, I need to get rid of the quotes on here. Very good. Okay, so we added true false. So now, does that mean we can unskip this test and get something that we would expect? Yes. So what we want here is a 4. So let's see, take this branch, take this branch. Is that kind of dumb? We'll just say this one. Just kind of visual clue of what's going on here. So this one's true, and then this one's false, so we jump down to the else. So we need to figure out what's going wrong here. I think it's the nested. Actually, let's do it this way. Let's just make a simpler test. We'll say if false, 2 and 3. This should be 3 or 4. There we go. Unknown instruction end if. Well, compiler, is that in the compiler or in the VM? That's in the VM. I guess that's true. We didn't handle end if. I think that's just a no op. Okay. Yes. So this one works, but this one fails. That one works. How does that work? Maybe I need to, I know there's a case where it's not going to work. True. 1, 2, 3. This is the one we want. How does that work? Maybe, oh, if there's an if true to, let's say 1, else 2, make this a 3 and a 4. Ah, there we go. That's the failing case. Because they should not take this branch. It should take this branch, and it should take this branch, and we should get a 3, but we're getting a 2 because we don't understand nested if else's. And we can fix that with another stack. So we can say if stack, or if, do we even need to know the stack? I don't think so. We could just say if depth is 0 and maybe. Having a little bit of trouble with that one in my brain. Condition stack pop. My thinking was I could say if depth plus equals 1, if the instruction is another if, then we want to do if depth plus equals 1 again. Case when end if, and then we're going to subtract when we get out of an if. Does that also mean we need to do it down here? I'm looking for end if there. End if until it equals end if, and if depth is start if depth. Oh man, I'm not 100% sure on this. If depth. I don't think we need this one either. And if depth is the same as start if depth. Something like that. No. For nil class. So we blew past all the instructions. So this first, we're currently pointing at an if. So what if we did index plus equals 1 to skip over that one? And will that fix it? Still doesn't like this. End if. So I'm blowing past all the instructions. Okay, I was missing this start if depth here. Now let's abstract that a little bit. So this have a lot of duplication here. So we could say skip to next instruction by name, and the name is something. And then we can copy all of this. Okay, so if we have this start if depth and we say until this equals the name that we're looking for, let's hopefully that'll work. So now we can do get rid of that, and we can say skip to next instruction by name, and the name is else. I don't need this to be a keyword arg because there's only one. And this one is going to be an end if. Yeah. Okay, I think that works. So let's just add a couple more to verify that this is doing what we would expect it to do. True. Change this to a false, and this to a false. So this one, so we're looking for the number 2 here. Is that lined up? 2. Very good. And let's just throw one more in there just for good measure. If false, false. So this one, I believe, yeah, this should be a 4. Very good. Yay. It works. If I use if expressions. So we added if expressions. We fixed the problem with our methods having to be defined in a certain order. We did all kinds of stuff. Yeah. Day 10. So what do we need for the next video then? So we've got methods with arguments. We have if. Oh, we don't have else if. Okay, but we can approximate that with nested ifs, yeah. Actually, I believe that the parser handles this potentially. So if I say else if false 3, 4, 5, does that get handled? It does, because if I change this to a true, that'll be a 3. Yeah. The parser actually handles the nesting of ifs and else ifs. Just to show what that looks like, we can say print compile, or yeah, compiler. Let's do it in the compiler. Print the AST. If false, if false. Yeah, I don't think we could really see it as well as I was thinking, because it's just going to look like some nested ifs. So let 4, let 5. Yeah, I guess you just have to trust me. We handle the else if in the parser, which I think is pretty cool. Let's go ahead and commit that as well. Well, there you go. What do we need? What do we need? So we need some math operations. We need minus and plus, and equality checking. So those are sort of built-in Ruby methods, and so we need to think of a way of exposing those to our little VM. Also, the compiler needs to know about them so that it can decide, you know, what type to expect for the left-hand side, the right-hand side, and then what type it returns. So we're going to have to teach the compiler about our little operators, at least these 3, and that'll be a lot of fun. Yeah, so I guess that's it for this video. Got a little longer than I had originally planned, but I think we did some really cool stuff, and I'm pretty proud of that. I guess that's it for now. I guess I'll see you in the next video. Bye.